Welcome to our DC microgrid and control system. Today we shall discuss mostly the theoretical as well today, that is application of the DC microgrids. So, where we will find potential and its applications. So, our presentation layout today will be based on its introduction, thereafter different kind of idle park, tidal park and all those amusement park. So, where we can fit the DC microgrid is a right suitable option. So, let us go back to the little history. That was a famous battle between Nikola Tesla and the Thomas Alva Edison. So, first commercial electric power system was developed by Thomas Alva Edison in 1882, as long as that time, at the Pearl Street stations in New York to deliver electricity produced by central DC dynamos. So, that at that time there was a DC generator. So, we had a DC dynamos and the supply voltage was 110 volt. Still US continue with this voltage even though it is now AC over the underground copper cable. So, thereafter those who know little bit of history of the electrical sciences, they know that, or electrical engineering, they know that modern transmission and distribution system ultimately follows the philosophy and application of the Nikola Tesla, and Nikola Tesla shows that AC has definitely merits over DC, and but that time power electronics was absent. So, Thomas Alva Edison required to be supported by the power electronics, since that was absent that time. Ultimately Thomas Alva Edison lose the battle like anything, but with the help of the power electronics, again the concept of the DC has rejuvenated, and thus there was a problem in that and that time. So, due to the low transmission voltage, Edison's power system had a high losses, because it cannot transmit bulk power, because if you want to transmit bulk power at low voltage, current required to be high, and thus your losses will be more. High cost of the copper conduction due to the high current, and small service area maximum of 1 and 2 miles. So, in between you require to you can supply. So, you require to put your generator only 1 to 2 kilometer away from the load center. And on the other hand, Westinghouse, there the person who was the Nikola Tesla demonstrated, it is because in USA it is 60 hertz, because all are the multiple of 60. So, they wanted to have a 60 hertz. Demonstrated first commercial AC power system in America, and just 40 years later, that is 1886, which could transmit the power at high voltage using transformer, and since it is a stationary solution, it will have a small losses over the wide area. And in 1888, the so called war of current began, versus AC versus DC, the famous battle between the two school of thoughts. One is Thomas Alva Edison, that was supported by GE, and another by this Westinghouse, led by Nikola Tesla. This war of the in this war of current, despite Edison's argument regarding safety of AC power system of Westinghouse prevailed. Ultimately, Nikola Tesla win the battle conclusively. Why? Because we are all having, we have faced out DC nowadays, but again it is resurfacing. Why we require to know this? Now, despite of the widespread use of the AC power produced by the large centralized power stations spanning 20th century as well as the 21st century, the DC power continued to show its presence at few restricted places, such as communication system. Communication tower require the DC power, control and protection applications of the power plants and substations. If you go to any Power plant, you will find huge battery bank to start the alternator, because that field current should come from that storage element once you want to start it, the electricity. And for this reason you require a backup power, and that backup excitation current comes from DC. And though modern railway drives are AC, but locomotives, mainly the local trains and all, these are DC drive and tractions. And there is a historical reason, since that DC motor was running, and we know that DC motor control very well. All the lead machines which was running has a longevity maybe actually 50 years. They still running, that is by the DC motors. Ultimately we require to retrofit it, and thus we find that power electronics application of rectifier there, and industrial drives and its etc., where DC finds is still been practiced because of the high starting torque. Because why we prefer in a railway, because of the it starts as a DC series motor with a high starting torque, thereafter it will change over to the shunt motor. So, anyway, and those kind, and also in case of the as you know that DC shunt motor, the torque speed characteristics is moreover constant, and thus you can have a wide range of speed variation with a different kind of with a constant torque. In that application DC motor were preferred, because at that time the complex AC drives like V/F control and the vector control was not invented, and thus it is gradually phasing out. But again we have totally a DC system, because we had a telecommunication is DC, your mobile charger is DC, telephone towers are DC, control and protections of the power system units, relay and all those elements require DC power supply. Apart from that, your tractions, mostly electrical traction which is used in electric drives, mostly railways, are DC, and because of the high starting torque. And the industrial system, because of the wide range of speed variation with constant torque and high to low speed. So, these are the few advantages since DC gives, we fail to replace DC in totally. Now, the development of the now comes into the picture. Development of the power electronics also enable to use in AC system to have that features, like you have a V/F control, and thus you can have a varied speed of variations at a constant torque. So, you know, and if you require a high starting torque also possible by V/F or vector control, and independent control of the torque and speed is also possible, like separately excited DC motor in induction machine by vector control. So, that where role of the power electronics comes into the picture, and which is fitted to the front end of the induction motor. And but then we must say that then we no longer require a DC, but it is reversed, since there is a rectification stage, it is better to have a DC system. So, let us see that the development in power electronics technology infused in a fresh life of the DC power system, because why power electronics exist, in my opinion, we do not have a transformer in DC, and generally the induction machines are constant speed machine at a constant power supply. So, you require a variable frequency power supply, but and due to those two reasons mainly we require a power electronics. So, by providing the better control of the DC power and making it possible to step up and step down the DC voltages, so again it rejuvenates the DC power supply, DC power flow and all those issues. Now, you have HVDC transmission also, but we are talking about in a distribution level, not in a transmission level for time being. The microgrid or the DC distribution system offer higher efficiency by avoiding multiple conversion. So, generally what happen, once you have adjustable speed drive what I was talking, because induction machine are constant frequency machine. Once you want to have a mimic the characteristics of the separately excited DC motor having a wide range of speed variation and a constant torque, then you require to rectify it. Thereafter you require to put a front end inverter, and that is you require a multiple stage AC to DC AC conversion. And for this reason, to avoid it, it is rather preferable the DC microgrid, where the conversion stages will be less, which we have seen in a previous lectures. And thus what you can say is that the microgrid or the distribution system offer high efficiency by avoiding multiple conversion, relatively less complexity of control, no reactive power and frequency control, because you know the even if in the AC system we have a droop control where both and frequency matters, because frequency is related to the real power and the voltage related to the reactive power. In that way you require to control the PQ of the of this microgrid. But if it is a DC, then those complex control is not required. You can only control the voltage and your requirement will be fulfilled. And for this reason, it is relatively less complex to control and no reactive power and the frequency control, and thus you have a reduced size and cost and the weight. Because you know RMS, if it is a fundamental, forget, you know, the DC does not have a skin effect. AC generally have a skin effect, and due to the advent of the power electronics, we are putting garbages of the harmonics into the power system, and due to the skin effect, the effective conduction area of the conductant get reduced. So, if you try to transmit the same amount of the power, DC require less cross sectional area, thus less cost of the copper, thus less cost of the conductor, but AC require more cost of the copper and more cost of the conductor, though this is a whole issue of the power quality. But what we can say is that it reduces the size, weight and the cost once you have a DC transmission. Taking into the account of the advantage of the DC microgrid, all those mentioned in previous slides, their usage has been proposed in a number of different applications in the smart grid and their own specific requirement. So, once instead of the dumb gate, we can have a smart gate, smart load. So, where it can monitor its orientation and control from the load point of view and source point of view, where source and loads are interchangeable, we require a bidirectional power flow, all those possibilities which we have discussed, as well as future distribution network integrated to the various technologies such as distributed energy resources, DER, smart building, it will generate its own consumption, zero peak building. So, smart buildings has many features. It may be have a zero peak building, like your peak you do not allow that load to be go into some peak, you have flattened your peak by your storage element. And plug-in electric vehicles, all those are the features where DC to DC converter is used, and where you find that DC microgrid has a huge potential, or and I rather say that it is already been used. So, application of the DC microgrid to future smart grids. You see that since I am telling future, it is in a research domain, it is a full concept, proof of concept is quite fine, and there are many papers on the smart grid, but very few are practically operated in the system, and for this reason we are telling it future. Otherwise, it is not at a future, it has its age has come, and we will find only over a decade only the smart grids. So, this is the renewable energy park, and you have a AC utility mains, and from there you may have a electric charging stations, and these are the different kind of loads. You may have a centralized washing machines with dryer, so that will take power and wash it, and wash the cloth, and when power tariff or the is less and the energy is available from the renewable energy sources. This is a high voltage DC bus of 380 volt. Then you may have your household utilities, which is generally connected in single phase, that will be connected. So, these are your refrigerator, your air conditioning, you require to boost it 48 to the required voltage level, but nowadays you are feeding with a V by F control and it does not matter. And thereafter you may have a 24 volt, and there you will use a ceiling fan. Please understand wattage matters. If it is a 24 volt, then nowadays your present technology will the VLDC motor, your ceiling fan can consume around 50 watt. So, there you can use this motor with the V by F control, and you may require to boost it little bit, and thus you can apply it properly. These can be the mobile charger, and this is the LED lighting. Similarly, these two are the large voltage applications for charging battery. It may be 400 volt or 380 volt charging. Apart from that, you require a huge storage element. You may have a supercapacitor. Supercapacitor, you will ensure that any instantaneous mismatch over a period of minutes has been catered. So, there to minimize the transient response or the power mismatch in minutes, it will be supported by, because if you have all of a sudden if you throw out an extra load, then bus voltage will swell up, and you cannot take that amount of extra power, extra transient instantaneously by your battery bank, and so extra power has to channelized into the ultra capacitor. And similarly, if you have a plug and play kind of system, you switch on the load, and definitely once you switch on a load, this battery are the slow system, it cannot increase the current instantaneously. So, that extra current to balance this power balance in that particular bus can be catered by the ultra capacitor. Thereafter, you may have a storage in the form of the chemical energy. So, you may have there is a different kind of concept, electrolyzer, then you store it as a hydrogen fuel. Since you burn hydrogen, you will get only the water, you will not cause any pollutions. And apart from that, you have a batteries, and thereafter maybe you got a fuel cell, and you are supplying the hydrogen into the fuel cell, and that is converted into the electrical energy, and that also pump power. So, in that way it will work. So, electrolyzer essentially will produce the hydrogen, then it will store into the tank, and ultimately it will fit the power to the fuel cell, and whenever there is a power in the fuel cell, it will be actually again transmitting this power to this battery and other. There is a multiple storage element depending on the time and size, different storage element are possible. So, as I have explained it, so this is the figure 1 shows the high efficiency household. So, we have all these households are very intelligent V by F control modern machines, V by F or vector control inverter fed modern machines, and we have a renewable energy park. From there we have a solar, wind and all those energy pumped into the system, this one. There are hybrid energy system. So, this is the hybrid storage energy system, and the electric vehicle fast charging. So, all integrated in a single place will be said to be a smart DC grid. So, let us discuss about the performance requirement of the DC microgrid and applications. From the control point of view, the microgrid should be operated in a stable way. to provide sufficient power quality at the point of common coupling. That means, once it is the entry point of the grid, there it should not throw any garbage. So, entry has to be through the active rectifier. Moreover, it should provide functionalities such as intelligent coordination and its internal units, as well as grid support capability when it is in the grid connected mode. So, that is also required to increase. You require to have a PQ control or other in a other way, so that you will be taking the desired power or despite desired power into the grid. Performance requirement for the DC microgrid application. The control point of view, it can be summarized as the stability. So, DC microgrid has to be stable, and for this reason we have a stabilizing element like ultra capacitors and all those batteries, and it has to be controlled properly by the droop control or any other method. So, what it says that sufficient stability margin during normal and the transient operating mode. So, when there is a load change, it should not throw the system out of instability. Power quality, that is, that issue comes into the picture in the point of common coupling, from the point where grid and the microgrid interacts. There you should not put the harmonics. Satisfactory voltage waveform in the common DC bus. Coordinated control, that we have discussed earlier. So, that is also required to do. Supervisory energy management system and responsible for the complex function. These are the, this may be power system, microgrid, time duration, maybe unit switching, it may be in a microgrid to the decade. So, we have to consider this item also. These are the economic dispatch, unit commitment, mode of changing of mode for aligning to the grid connected mode and vice versa, efficiency optimization and power flow between the two internal cluster. So, those are all required to be featured in a coordinated control. And from the architecture point of view, the functionalities that can be achieved through the appropriate power architecture could be following. That is redundancy. If one of the converter put off, then it is not that whole grid will shut down. So, you have a fault tolerant and the redundancy features. Redundant power supply for the load with the minimized reliance on the communications. So, if the communication channels are broken, then also you should be able to run your microgrid system. Let us say you communicate over Wi-Fi, if Wi-Fi is not there, your communication is lost, and that is one of the problem on the master slaves schemes. So, it is highly dependent on the communication channel. Flexibility, possibility of configuring the system online during faults and or from the microgrid clusters. Scalability, possibility to seamless add or remove unit within microgrids. Stability and power quality in control category can be represented as a characteristics of the system. So, that is something we require to be revisited again. So, now we talk about the highly efficient smart buildings. So, thus the high efficiency households. Since majority of the modern household energy sources and the loads are PV panel, batteries, LEDs, consumer electronics operate naturally in DC. So, it is more efficient to connect them around the DC bus in the microgrid. And in contrast to the traditional AC system, DC system has higher efficiency, because what happened, your conversion efficiency will be more. And since you have a, if you put these are all are essentially, this is source and you have to convert AC to DC to AC, and battery you require to charge and discharge, and you have to convert, and you have the help of the power electronics, and thus you have to compromise the efficiency. Same way LEDs, and most of the AC systems, you talk about the fluorescent bulb and all those lights and all those AC system, you will find efficiency is less because of the fact of the power factor. In absence of the power factor, DC systems are more reliable. If you say the 40-watt incandescent lamp, 40-watt fluorescent lamp, it will be around 10% less, it will be less than 36 watt in case of the DC. You can find it out. And also you may find that if it is not running in AC, it may run in DC. Longevity also will be higher. So, thereafter energy saving opportunity by changing the infrastructure from AC to DC, and it can leads to the saving of the energy by 15%. So, economics comes into the picture. What is the cost of payout of your investment? The benefit from efficiency point of view and the control simplicity in case of the DC makes it better option for integration of the energy management system. And so, we are gradually, when we have a scope of the solar installation, gradually we look for the DC microgrid. In order to achieve flexibility, it is important to establish coordinated control, because you have to give a responsibility of particular task to the particular entity, and like who will be the slack point, who will be the power point, which we have discussed in the previous lectures. Please refer my previous lecture. So, in order to achieve the flexibility, it is important to establish the coordinated control of appliances within the household, and it should be noted that integration of the local energy storage with controllable appliances can greatly aid the functionality, and that will help us to achieve the zero peak building and all those modern concepts. Most of the common objective in control of the future households are reduction of the energy cost and the maximum of the customer comfort. These are the whole requirement. If your energy is generated less, instead of the shutting down, you may run your AC a little higher temperature, and it is causing a really less uncomfortable to the consumers, but ultimately you can save the energy. So, that is the challenge. So, you ensure the comfort smart and without hampering, and also you cut down the cost. These objectives are most commonly achieved by scheduling appliances, that is, once you have a more power, you put those bulky loads at that time within the household through various unit commitment strategies. Now, we have discussed about the renewable energy park. So, renewable energy park is an evolving concept. Previously, when we were kids, so there was an energy park for the academic interest. Now, it is also a commercial interest. You can have a renewable energy park, that is solar, wind, all those concept has been put into the place, and in that area use planned for the purpose of the clean energy development like wind and the solar. And this renewable infrastructure can serve as a smart and the sustainable assets. It can promote the ecotourisms. It is, since it is a park, so it is a natural habitat. So, you can go for the healthy breathing. So, these assets areas are surplus of the industrial property, and this renewable energy park not only provide a source of the reliable locally produced clean energy, but they have also contributed to the ecotourism, that is what I am saying, and served as a educational resources to the local schools, university and the business groups. So, it has huge advantage to it. Okay, we shall continue with these discussions, application of the DC microgrid in our next class. Thank you for your attention.